I'm Kirk Harnack. On This Week in Radio Tech, hey, Tom Ray, Chris Tobin, and Chris Tarr are all here. And this week it's Gentlemen, Start Your Bulldozers, and a story about the Tennessee car zapper. That's coming up on This Week in Radio Tech next.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for This Week in Radio Tech is brought to you by Cachefly at CACHEFLY.com.
This is This Week in Radio Tech, episode 131, recorded May 30th, 2012. Tennessee car zapper. This Week in Radio Tech is brought to you by Omnia Audio and the new Omnia 11 FM. If you don't need it, why pay for it? The Omnia 11 doesn't have the HD section, but it has the great Omnia 11 sound for FM. On the web at omniaaudio.com/11. Hi, and welcome into This Week in Radio Tech. I'm Kirk Harnack, your host, and I'm awfully glad that you're along here. This is the show where me and usually 2 or 3 other engineers get together, talk about radio stuff. You know, radio's been around with us a long, long time, and engineers have been with radio the whole time. I mean, there hasn't been a time when we've had radio that we haven't had engineers to help make it and keep it working and sometimes break it and tell owners and managers and salespeople what they can and can't do with their radio technology. Joining me are a slew of broadcast professionals. Let's crank in broadcast professional number 1, the best dressed engineer in radio. From Manhattan, it's Chris Tobin. Hey, Chris, how are you?
Hello, everyone. I'm doing well. It's a great day in Manhattan. The weather's been just fine. Low humidity, and the heat has not hit us just yet. I'm president at CCS Musicam. For disclosure, I manufacture and sell audio IP codecs and video codecs for those of you out there, so there's no discrepancies. And I'm having a great time, and the summer is going to be fun. We got some good stuff coming up.
Good. I'm getting eager to hear about it. We've all got summer plans, summer engineering plans. So I've got a couple cool things to tell you about, too, on the show. Also with us, also from New York, but from the Hudson Valley of New York. He works in New York City. He commutes every day. It's Tom Ray from WOR and Buckley Broadcasting.
And I'm also a guy who likes to tell management exactly what they can do with their technology. But anyway, yes, I'm a VP, the Corporate Director of Engineering of Buckley Broadcasting, WOR Radio in New York, where if you follow my Facebook page, you will see that I've started my annual rant against tourists. So.
Yeah, I noticed that today. Yeah, you got nothing against tourists. It's just tourists on the sidewalk where you want to go. Now, Tom, are you advocating that tourists should hang out in the street? Would that be a better place?
No, I'm advocating that maybe they should move to the side because, you know, they love to congregate and stop in the middle of the sidewalk. And it's not one, it's 4 or 5 straight across the sidewalk. Ooh, look at the big building. It's New York. We have big buildings. Or, oh, look, there's a cemetery right here. And Alexander Hamilton's buried in it while they're reading their city guide, 4 or 5 of them standing in the middle of the sidewalk where you have to now walk in the street. It's like, good God, you know?
People can't live with them, can't live without them. What do you do? Also with us, the voice of reason and sensibility, it's the Ninjineer from Muckwonago, Wisconsin. It's Chris Tarr. Hey, Chris.
Hi there. Well, you know, we get tourists here, too. You know, the summer season, which is June to July. And, you know, we usually get a school bus or 2 of some people coming through town. Typically, the reason we get the tourists is we pull them over for speeding somewhere in town and collect the revenue. But, you know, other than that, I don't have a problem at all with our tourists. I'm the Director of Engineering for Intercom's radio stations in Milwaukee and Madison. I also am a contributing writer to Radio Guide magazine, and I'm co-founder of the website broadcastengineering.info, the virtual engineer.
Cool. Be sure to promote that website again at the end of the show because it's a darn good one. Hey, I forgot to warn Burke McQuinn, our producer, back in Petaluma at the TWiT Network. Burke, there's a URL that I've pasted in our private chat room, and we'd like to take a look at that if you can bring that up. And I'll begin by telling a bit of a story here. A few weeks ago, the Nashville chapter of the Society of Broadcast Engineers got to go on a field trip. We went to a transmitter site that is home of 3 shortwave transmitters. Now, this is a shortwave transmission for commercial purposes. And that's what these are. They're commercial shortwave stations. They're time brokered. Each transmitter is let out to a different organization. I think one organization has some ties and partial co-ownership with the transmitters themselves, but they're let out, and they are religious broadcasters transmitting all around the world. And this transmitter site is run by a fellow named George McClintock, and someday I'm going to get George on the show. The guy's fascinating, absolutely fascinating. He's just crazy enough to do this and do it very well. I posted some photos of this shortwave transmitter site on my Facebook page. And you can go find me on Facebook, no problem at all. I think my username is K Harnack, or it might be Kirk Harnack. But anyway, it shouldn't be too hard to find on Facebook. And there's several pictures there of these Continental transmitters. There's also a Harris shortwave transmitter in the building too. I didn't get as many pictures of that, and pictures of some of the feed line, the ladder line that goes out there. Hey, Burke, if we could show that picture, that URL that I gave you. I posted this on the TWiT Facebook page, not on my page, on the TWiT page, this particular picture, and I asked, who knows what this is? And this is just fascinating to figure out what this is and how it works. Some folks answered correctly. They said it's ladder line. But look at how it's built. It's kind of different than normal, ordinary ladder line. You guys want to discuss this for a minute? What do you think about it?
I'm guessing that's because of the amount of current that's going out to the antenna, that they have it doubled up like that. At least that's what I think.
That may be one reason, but let's look at that picture again. On the left-hand side, it's built like a square. It's actually kind of the cross section is a rectangle. So there's the right-hand side the upper and lower conductors there are tied together, and then there's insulators going horizontally across over to the left-hand side. And those conductors are also spaced apart from each other, although they are electrically connected to each other. And this goes along for a while until you get a little farther down the line, when the vertical amount of space between the conductors reduces to, and there you can see it just going off the left-hand side of the screen. It reduces to where it's the left conductors are closer together and the right conductors are closer together, but they're still the same distance apart from each other. And then it goes a little further, and then they reduce their spacing again until they come to the point where there is no spacing between the right conductors and the left conductors. They're made into one double conductor, and from there it goes on to the antenna. So I had no idea why this was. Does anybody else here know why? Somebody actually, I think, said it correctly on the Facebook page. Any guesses?
I don't know. Is that voltage dividing for various bands, or just, I'm trying to make out are those resistors that are going across horizontally?
No, they're just insulators. They're insulators.
Okay, good.
Well, several folks in the chat room have this right. Navion and Wenko have this right. It's their impedance transforms. This thing starts out at, I may have this exactly backwards, but it starts out, I believe, at 600 ohms of impedance on this ladder line. And then it goes down to either 300 or 150 or maybe even down to 75 ohms. But it's an impedance transform that's made into the line, and apparently reducing the spacing on the same side of these conductors. Well, of course, when they're spaced farther apart, I guess you sort of RF-wise, you have a larger conductor. You have you have a not really a larger surface area, but you got a larger sphere of influence or tube of influence. If they're like this, and then when they space down to this, they get smaller. Well, maybe that makes the impedance different. But
you also have different capacitance between the conductors when they're farther apart than when they're closer together, and that will also help with the impedance transformation. Now that I think about it, and it's a great idea, and ladder line itself tends to be not as lossy as a coax or anything else. So to be able to use the ladder line not only as a low loss medium, but also as the impedance transformer, and not putting a tuning network in, that's incredible. That's great.
Now, one thing I want to make clear about that picture, Burke, if we go back to the picture one more time, the spacing between the opposite polarities of the transmission line does not change. Okay, the plus side, if you will, and the minus side, the two different sides of this balanced line, do not change their distance from each other. The only thing that changes is that there are two parallel conductors conducting the same exact thing at the same time. And those two conductors are what get closer and closer together as this thing moves along. So the two conductors on the right side, they are at the same potential. And the two on the left side are at the same potential as the other on the left side. So to me, it's got to be a matter of when these things are spaced farther apart, they look like maybe their skin effect is like bigger, fatter conductors. But the actual width between them doesn't change. And that's what has me a little befuddled as to exactly how this works. Maybe we should get somebody from Kentronics on the show to explain what's going on here. But I thought it was pretty amazing. Yeah, we had people who said it right. So I got to go to this transmitter site, and I've got some other pictures. We're going to share them on another show. Maybe we can get George McClintock on with us, or one of his engineers, although George is an engineer in his own right. But a couple interesting things. This transmitter site, and it's, by the way, it's east of Nashville, about, 40, 45 miles or so. It's a good little hike past to the east of Lebanon, Tennessee. And it's way up. It's way off the beaten path. It's pretty close to the Tennessee, to a river, the Cumberland or Tennessee River, I forget which one. Anyway, on this piece of property, there are 3 rhombic antennas. So a rhombic is held up by a pattern of telephone poles, right? And there are multiple conductors in the rhombic, maybe just to handle, give it greater bandwidth, I suppose. And then generally speaking, the rhombic is thought to fire off the end of it, more or less. Although George McClintock says, the directionality is just not that great. And some people terminate the far end of the rhombic, and others don't. He says that his rhombic is not terminated, and for whatever reason, found that that's actually better for him. But anyway, I was going to say, when you drive into this transmitter site, the road from the main road, if you can call it the main road, from the main road, the driveway going in toward the transmitter building goes right under the middle of this big rhombic antenna that's throwing signal over to Africa and the southern part of Europe. And there are plenty of vehicles whose electrical systems have no idea what to do with all that RF. So George McClintock put out a notice to all the SBE members who were arriving at this location for our meeting. He said, if you drive in and your car stalls, here's my phone number, because your cell phone will probably work. Here's my phone number. Call me. We'll shut the transmitter off, and you can restart your car and drive on in, and then we'll turn the transmitter back on. So I'm thinking, okay, I'm driving my car is a 1999 Toyota 4Runner. And I had absolutely no idea how it would behave in this kind of RF environment. Of course, I drive it, or have driven it, right up next to 50 kilowatt AM transmitter sites, but these were Marconi antennas. These, vertical quarter wave or half wave radiators. So I'm driving to this site, and I'm kind of thinking, is my car going to cut off? Am I going to be all right? And I'm watching the dashboard, I'm watching the lights, and so far nothing's happening. I'm driving on in, and I get right about to the center of this rhombic, and I can see it's all around me. And the only thing that goes crazy, and something does happen, in my car, the blower for the HVAC system, the blower goes to full blast, and then dead. And then full blast again, and then dead. And by that time, I'd kind of passed through the middle of it and gotten out of the middle of this rhombic, pulled up into the parking lot, and the blower was fine. And the car stopped fine. And when I left, it started right back up. So that was kind of, whatever electronic system in this 99 Toyota 4Runner runs that fan. And it's not a mechanical switch. It's an electronic control in that car.
So essentially, your fan turned into a modulation monitor. Went from 100 to 0 to 50 to 100.
And actually, most vehicles are spec'd for HF frequencies at about 100 watts, a little bit more. So, they tell you can put an HF radio in the car up to 100 watts, but don't exceed that. So, Kirk, I think you exceeded that.
Absolutely. Well, my next vehicle may just have to be a Nissan. Now, they build a bunch of Nissans just down the road from me in Smyrna, Tennessee. So they're built, at least certain models are built locally. And George McClintock told me that every year, sometimes twice a year, engineers from Nissan will bring a whole bunch of brand new cars out to his transmitter site. And they'll drive under this rhombic antenna and see what goes wrong, if anything. And he says that for several years now, nothing's gone wrong. They've apparently got it figured out pretty well, how to keep 100 kilowatts of 10 megahertz or approximately, wherever they're transmitting at that time, out of the car.
That's funny.
Yeah.
That's funny. I like that.
I'm impressed that an auto manufacturer would do that they would take the trouble to drive. It's got to be it's over an hour drive from the Nissan factory in Smyrna out well east of Lebanon, Tennessee, to go drive under this thing. And of course, transmitters got to all be up and running. So wow, that was pretty interesting. Oh, I you know what? I did hear a little bit of sound in my car speakers, although I couldn't make out what it was. So it wasn't a perfect demodulation. So that was interesting. I don't want to foreshadow too much of any future show with George, but I will say if you go to my Facebook page, you'll see some pictures of these Continental transmitters. And George McClintock, he's what you might call he's a frugal man. That's the best way to say. He's a frugal man. And so George, now you can see he spared no expense on this antenna. I mean, I got Kintronic to design this thing for him. And actually, Burke, if you're looking around, it's my personal Facebook page, not the TWiT show Facebook page that's got a few pictures. So he gets these transmitters. He's gotten 2 Continental transmitters from various sources. And I think one was from the island of Seychelles. And I forget where the other one was from, some far-off land. And the prior owners had given up on these transmitters. They had been modified and hacked and put up with salt air over the years, over the decades. So George gets these transmitters for little to nothing and hauls them back to the U.S. and puts these things in place. And apparently the big thing that he's had to do is replace the modulator section. So that's the modulator section is external to the transmitter. Some facilities will put the modulation section in the basement. At WTWW, they're behind the transmitters, and they're at the big fenced-off, caged area where there's big honking transformers. And I don't know the schematic diagram of what all these things do. I think it's pulse width modulation on these, and there's a fair amount of fiber optics. Getting signal to the various modules, which seems pretty smart. So,
actually, the Harris is probably a pulse width modulated. The Continentals most likely is a Doherty amplifier because that's what they specialized in.
That's right, they did, but I only recall the transmitter itself as having one tube in the cabinet. And wouldn't a Doherty require 2 tubes?
In the final amplifier, yeah. For a Doherty, yeah, you'd require 2 tubes 90 degrees out of phase.
Yeah. So that's I'm sorry. There was so much to look at that I just couldn't ask all the questions that I wanted to, like, hey, how's this thing modulate? But I do know that the modulator sections had lots and lots of boards with big honking blue capacitors and like I said, fiber optic signaling, and maybe for some monitoring and control as well. And then these 2 huge 3-phase power transformers. So just amazing stuff, and we'll get a look at it some other time. There's a video on YouTube that if you go to my Facebook page, you can get a link to it there too. There's a video with George McClintock giving a bit of a tour. So with that, all that said, I just thought this high power transmitter site was absolutely fascinating. I wonder if you guys had ever had any chance to go to a high powered transmitter site. And hey, I know you take care of 50 kilowatt AMs, nothing to sneeze at. Have you been to any other transmitter sites that were of such or greater power?
Well, Chris Tobin's been to one. The WCBS and WFAN transmitter site in New York City combines both of those stations into one. It's 100 kilowatts going into the base of the tower.
Oh yeah, it's 100 kilowatts, 2 stations diplex together. I don't think there are any others in the country. If there are, they're probably shortwave. I'd say, oh boy, it's a lot of RF, a lot of voltage in the air. The fun part is taking fluorescent bulbs, and before you even walk into the tuning house, they're lighting up already. Yeah, it's 250 kilowatts diplexed onto a single tower. Two sets of tuning arrangements, and the currents across the tower section itself are quite high. And we had an FCC inspection one time, and because it's 2 radio stations, you can imagine the current at the base of the tower is double what you normally would see. So a typical 50 kilowatt, maybe of this size, would be about 32, 33 amps. But in the case of 2 radio stations, you're close to 60, 70 amps. FCC is like, no, this is all wrong. You got a problem. You're out of tolerance. We're like, no, you don't understand it. We're diplexing 2 stations here. They're 2 separate. Let me back up. You have to understand, at the WCBS site, it's 2 radio stations, WFAN and WCBS. Well, back in the day, it was WCBS AM and WNBC, 2 separately owned radio stations, 2 separate companies. They were not co-owned. So there was 2 separate buildings, 2 separate dog houses that fed into the single tower. So everything was separate. Now that they're under one ownership under CBS, WFAN and WCBS, it's, you don't realize it's just one company, one radio station. And people come out, they say, oh, it's just one antenna, one transmitter. It's like, no, 2 separate transmitters still feeding a single tower, but they're co-owned. And it's wild. There's a lot going on out there. And the buildings are well insulated with with copper screening, grounding. Yes, you could probably draw an arc off of some connections if you're not properly grounded in the building. We do have phone service that works very, very well, as long as it stays grounded. Verizon, in the early days, did have a tough time trying to make things work a certain way, but they've gotten past that. It's just, there's a lot of RF. I will say that another site that I drove past, I did not work at, I did not have any affiliation with, was on the eastern end of Long Island, and it was actually a government installation. It's still there, but they don't officially acknowledge it. It's a HF, shortwave, some type of communication system. All I can say is if you decide to park along the fence and look over the trees to see what's going on in the tower structures, a vehicle does come up alongside you, would like to know, state your business. The people that do ask those questions are carrying firearms and do have their hands on the firearm. That's all I can tell you. Yes, but it is a high-powered communications facility, well hidden behind 1, 2, 3 rows of pine trees, 2 sets of fences, and that's all you can see. So that's the other high-powered facility I did have an opportunity to go past, but that's the closest I got. Anything closer, I'd not be here to talk about it.
Wow! And I've been out to I've been out to Colorado to the site of WWV and WWVB.
Oh, that's good.
Time station. Interesting show some night, Kirk. Because you have, let's see, 2.5, 5, 10, 15, and 20 megahertz. So you've got 5 transmitters there operating with separate antennas, operating at 10 kilowatts each. And then you've got the low-frequency station, WWVB, which is 60 kilohertz.
Oh, my goodness.
At 50 kilowatts effective radiated power. So they're putting about 78 kilowatts into that antenna to get 50 kilowatts out because of the efficiency. The antenna's not long enough.
Oh, geez. So what does – I'm sorry, describe it. What does the antenna look like for the 60 kilohertz? I realize it's not long enough. That'd be really long.
Actually, believe it or not, it's a directional antenna. It consists of a 400-foot drop wire, and it has a capacitance hat. So they have wires coming off the top for a capacitance hat to top load the tower, and it comes down, and it comes down to a lead which goes into the tuning house. And in the tuning house, they've got this big mother coil called a variometer, which is automatic adjustment. I mean, the thing is huge. And I did a quick calculation. I figured out, okay, for what they were doing, I figured out roughly what the quote-unquote base impedance of the antenna was. I'm guessing 300 amps feeding into that tower, that drop wire. But they have 2 of them. They're separated. I'm going to have to go back and look at my notes. It's been a while since I've seen it, but they're separated by something like a quarter mile or an eighth of a mile. And it forms a directional pattern that sends the load primarily down across the eastern and southeastern United States. It was fascinating. And matter of fact, my watch sets by WWVB, and it is technically, if you want to get down to it, it's a Morse code signal that they feed out.
Huh.
And the real interesting thing about the site is when you start talking the atomic clocks and everything else. When it comes for something like daylight savings time, the stupid human has to show up and push the button to say, "Okay, tonight's the night." It's not automatic.
Oh my goodness!
That's how you have accuracy. That's the accuracy behind it.
Yep.
I wonder if Burke is. I got another pick here. I guess this is actually working out to be a pretty interesting show of talking about this high power stuff. Burke, I sent you another link. I don't know if you can show that or not. It's it's a picture on my Picasso web site. There we go. All right, this, gentlemen, is one of the modulators that was rebuilt with new stuff behind one of the Continental transmitters. So this is as much a part of the transmitter as what's in the transmitter cabinets, which are off to the right. So on the left-hand side, you see there are two big three-phase transformers. Those right there, I'm told, were actually made in China, and they cost less than the American-made ones that were also an option, and I'm like a lot less. And then over on the right-hand side are all these amplifier boards, and although you can't see the heat sink mounted transistors, they do exist behind the green PC boards over there. I may have another picture of them elsewhere. Now, what I'm not sure about is what is the huge coil there in the middle? Is that a low pass filter? Seems like a lot of work there for a low pass filter.
Could be a low pass filter if they're using pulse duration modulation, because you'd have to filter out the pulse train. I'm thinking could be a phasing coil, but I don't think so. I'd have to see the schematic on the transmitter, and I might be able to download it from Continental's website. And actually, with these transmitters, the thing that really amazes me, they set up on different frequencies. This particular, the 418G from Continental, which is their 100 kilowatt shortwave transmitter. You can set 280 preset frequency channels, and it will tune between any two frequencies in 30 seconds. That fascinates me. It really does.
And 30 seconds, to somebody who hasn't been inside one of these transmitters thinks, well, that's a long time to switch frequencies. I mean, I can change other things a whole lot faster. Well, there's a lot of mechanical going on inside the transmitter to get all the tuning coils and capacitors set to the right place. Hey, there's another picture worth looking at. Burke can. Oh, okay. Well, Burke's got several other pictures he might show us here, and that's fine. This is the plate from one of those transformers. This is one of the ones made in China, if I'm not mistaken. And then there was. Oh yeah, this is the one I wanted to show you here. Not many transmitters in radio have a meter that shows the water resistivity. Now, that sign got cut off at bottom or top of what Burke is showing us here. I forget if it's bottom or top there. It should say, yeah, there you go. Water resistivity. Not a figure you often have to log on a radio station's transmitter. Chris, Tarr, you got any transmitters that where you have to check out the water resistivity?
Let me think. No.
Now, I guess those guys who are in TV, if you've got a water-cooled or a vapor-cooled transmitter, then you're going to have this. Now, back to this picture. This water resistivity. See, they're actually running water to cool the tube. Now, you'd think water conducts electricity. Well, pure water does not, or at least not very well. And so the water resistivity measurement is kind of a measurement of how pure the water is. And over time, it gets impurities in it. You get some rust particles or whatever leaches off the pipes and or out of the pump. Little specks of metal from the pump impeller, and it becomes more and more conductive over time. But pure distilled water doesn't conduct electricity. So the resistivity there, I don't know how long of a area that it measures, but it was just reading 1.54 megohms, and it's got to read above a megohm, otherwise they got to change the water out. So that's another very interesting thing, I think. And as a radio engineer, I've never had to deal with a water-cooled transmitter or all the, can you imagine the complexities and just the mechanical crap to deal with running, let's see, here's a whole bunch of water and here's 30,000 volts. And I got to run one right by the other.
In the same room. In the
same room, in the same piece of equipment. Yeah.
Sounds like a challenge to me.
Yeah, it sure does. It sure does.
Wow.
If I don't know, Burke, you're picking some good pictures here to show us. There's also a picture of a water pump. It's that kind of down here, about 3/4 the way through the feed there. If you want to show that, and there's some other wiring pictures. Burke, if you just want to pick a couple pictures to show, we'll be glad to chat about them for a few minutes. By the way, if you've just tuned in, you are watching or listening to This Week in Radio Tech. It's a show where usually me and sometimes some other engineers get together and we talk about radio technology. With me are Chris Tobin from New York City, a former engineer for CBS Radio and currently is the president of CCM Musicam CCS here in the U.S. Also, Tom Ray is with us. He's the engineer for WOR and Buckley Broadcasting. And also Chris Tarr with Entercom in Milwaukee is with us. So we thank you for tuning in. So he's an engineer. Mm-hmm. The evil eye.
Hey, Kirk.
Yeah.
That big inductor you were looking at before. You're right.
Yeah.
That is a low pass filter
for the PDM.
Well, it doesn't. I'm reading here. I'm reading a modification for the for DRM, and it's talking about retapping the low pass filter inductor L1, which is what we were looking at.
Huh.
So. But it doesn't say exactly what L1 does. I'm going to read through this a little more, and maybe I'll let you know as soon as I find it.
Well, earlier in the show, I alluded to our summer projects. And by the way, Burke, if you got another picture you want to show us, have you picked something out that looks interesting, or shall we move on to the next subject? Okay. Well, yeah, here's a little better picture of some of this modulator section, and you can see some of the heat sinks that are there. If you look closely on the right-hand side down low, you could see some of the fiber optic cables that are sheathed in gray. And I'm not sure where they go to or from. I didn't get into finding out about that. But I do know that they, on a reasonably regular basis, have to perform repairs to these circuit boards. Don't have too many connections to them, the fiber optic and just a few wires, but I'm pretty sure there's some good size transistor devices between the board and the heatsink. I know they've spent a fair amount of time repairing those boards and getting them modified. So, little foreshadowing. In the next few weeks, I've got a couple of really interesting trips myself to see some broadcasters. I hope to bring back some good pictures and maybe some interviews. Yours truly, I'm going to Hong Kong and Beijing and in June. And then in July, I'm going to Taipei and Manila. So we get to meet some broadcasters there, and I will bring back all the pictures and photos and maybe some video interviews that I possibly can and share them with you guys. Mostly I'm going to studio sites, but if I can get to a transmitter site or two, I certainly will. Also this summer, I've got a project coming up. I'm going to install a couple of audio consoles in American Samoa. So that's the kind of place where, there's no Radio Shack in American Samoa. So you got to try to make sure you got everything there, because if you need something, if you forgot something, it's going to be a week getting there, even by the U.S. mail, express mail delivery. Well, it might be 3 or 4 days, but it's if you discover you need something just 2 days before you have to leave, you're pretty much out of luck. Hey, let's check in with Chris Tarr. Chris, you've got some projects this summer. Anything you can tell us about?
Oh, boy, yeah, lots of stuff going on. What we're doing, we just broke ground this morning for the building expansion project we're doing at our Milwaukee facility. We're actually adding on an addition and hope to get some studios remodeled and some equipment done. It's been a long time coming. It's funny when you take on these projects. They're many years in the making. And so, you start out several years ago when the consoles really needed to be replaced and said, well, we'll just hold off because we're doing this large project and, we just got to keep them holding on until we actually get everything together. So, we've been kind of kicking the can down the road. Finally, it's here. So actually just this morning, they're out doing the grading. We have to actually put in a new parking lot. And then because the area that we're going to be putting the addition onto is going to go into the current parking lot. So we have to actually clear out some stuff and make some room for the new parking lot to go into. And then that way we can start clearing out the other parking lot to get this done. So it's kind of a multi-stage project. And actually, we probably won't be starting the building portion of it till September. And then they'll be working through the winter doing the interior work and the couple of the new studios that we're building and that sort of thing. So it's a multi-stage project. It was real exciting just to see some movement. It's been several years in the making getting this done, and to have see the land being graded and the lot being changed up is pretty exciting.
Chris, you posted a photo of some work guys got done today, and I sent the link to Burke, but I'm not sure if it's shared with the world or not. Any luck on that, Burke?
Maybe not.
Okay, nope, not happening. Nope, sorry. Well, it's a bunch of dirt, but you know what? As engineers, we look at a field full of dirt and we see, what's coming. We see studios and brick walls and double pane glass and audio and computer networks and audio consoles and stuff like that going in. Is that what you're imagining? And by the way, the building expansion, is that where your new studios are going, or are you remodeling the old studios?
We're actually doing a kind of a combination. We haven't done the entire planning yet. It's kind of still a work in progress. But the plan at this point is we're building an addition, and we're going to put in a new conference room there, and then also there we go. I'm just getting the link here for some of the digging. What we're going to be doing is putting in a new conference room, and then at this point we're looking at building 2 new studios and then taking the 2 others and stripping them down basically to the walls and rebuilding them and remodeling them. So really at the end, the end result is going to be 4 new studios. And so we're pretty excited about that. But it is, like I said, it's an interesting project because where we're building, and I just sent the link there for some pictures, where we're building is out into the parking lot. So before we can do anything, obviously we have to have a place where people can park. So we got to get the grading done and the parking lot in so that people can park. Then we can worry about, taking out the parking that we currently have to do the foundations and that sort of thing. So it's really a multi-stage project. And, it probably – we should be wrapping up about a year from now is really when it'll be finally all done.
You've got so much stuff at your site there. You've got AM transmission going on there, right?
Yeah. I've got an AM and an FM on site, and then one of the stations is off site there.
And since you have an AM on site, I know somebody asked you on your Facebook page, Chris. What about ground radios? Did you look out for those, or did the bulldozer catch some? What's your answer to that?
No,
How do you take care of that?
We got lucky, and the reason is because the people who were here long before me didn't do the job right. So I got kind of lucky in that there are no the building was there first. That the towers actually came later because they went from a 7-tower array to a 5-tower array, and when they did that, they didn't run radials near the front of the old building. And not only that, but then where we're putting the parking lot now, there was another structure there. So we had an area near the tower that didn't have ground radials around it. So, I staked out that area that didn't. And then, I said, anything beyond these stakes are off limits. That's where our ground radials are. But anything in here, we're in good shape. But it's not a huge portion. But there's a good chunk right in front of our and Kirk's you've been to our to my site. There's actually an old transmitter building on the lot, and that older building right in front there is where this digging is. There were no ground radials there, so we were lucky there. So that picture was actually what I took this morning when the guys first started digging, and they had just gotten started. We were still, I was still a little nervous because I was like, well, I know where there's no ground radials there, but, I'm just envisioning seeing little curly cues of copper coming up out of the ground. Fortunately, that wasn't the case.
Have you ever had to do that? Have you ever had to cut a path? For those who may not know, AM radio stations, almost all of them have to have copper wires underground emanating like spokes from the tower or the tower area. And this provides an electronic counterpoise. It sort of forms a capacitance with the tower, and it also just gives the station a good ground. And these copper wires called ground radials, they typically extend a quarter of a wavelength, whatever the frequency is, a quarter of a wavelength from the tower out in all directions, 360 degrees. And usually there's typically 120 buried copper wires. They're spaced typically every 3 degrees apart, which gives you, all the way around the circle, 120 of them. And if you're going to do some work, you don't want to tear these things up because they're important to the stability of your single tower or multi-tower array, and they're critical for the signal actually getting out. Now, there are some ways to get around having ground radials or some ways of kind of not foreshortening, but having a raised ground system, for example, you can do with fewer radials, supposedly. But you can't tear these things up, and if you do, you got to figure out how am I going to put them back together.
I've got a good story for that. There was actually a building that we were building next to a transitor site. Transitor site originally just had a doghouse, and the building was fairly far away with a transmission line run coming into where the doghouse was, right at the base of the tower. Well, we sold that land and had to build a building right next to the tower. So we hired a contractor who actually has done these transitor sites before with a prefab building. And I said, okay, we have ground radials in the ground here. So you can't dig very deep at all for this building. You can dig a little bit and then put the foundations in. But I need to be there, and we need to make sure that we don't pull up any of these wires. Oh, yeah, no problem. We got it. So it turns out this transitor site was right on my way home. So I was coming home for the day, and I drive by, and something caught my eye, and I stopped and backed up, looked into the driveway, and there was a backhoe and a bunch of copper wires sitting up in the air, all kind of flung around. And, they went in and they tore it up. I mean, just copper everywhere. So what we ended up having to do is when we put the building in, the foundation for the building, we put in a copper strap around the base of the building and then had to go back and solder those wires on there on either end of the, and continue it around this ring. So you had the copper wires on the backside, had to bring in, tack those onto the strap around the building. Then the copper wires that were pulled up on the other side, had to bring those in and tack them on to the other side of the building so that we had the continuity there. Okay. But you can't imagine how angry I was when I drove by and saw this copper just flinging up in the air. And I asked him, like, at what point did you maybe stop and look at this and go, this is unusual. I don't know that this is right. Probably the first time you brought up a big bucket full of copper, I would have stopped at that point and made a couple of phone calls. I don't know about you. So, and that's, like I said, so that was my fear this morning as I pulled in. I had this fear of pulling in and seeing, a bunch of copper wire coming up out of the ground. And, fortunately, not this time. But the one interesting thing about this dig is it was, and part of the reason also why I wasn't too worried about ground wires and everything is it's actually built. They filled it up, so whatever is left of the ground wires under that they didn't, that would have been there, are way buried down in there. Now that's not a copper wire; that's actually something else. But what we had is there was a prefab building that was on that site. Right in front of that building where the original studios were. And it was kind of like looking at an old an old archaeological dig. They cleared it all out. There were chunks of, foam insulation, old wires. You could see the big electrical conductors coming from the old building into the site there, and the old audio cabling that was running between the two buildings. All of that was still buried underground. So there were a few artifacts that we found this morning as we were walking around where they excavated. So anyway, that's the big project, and the joke going on now is that if I survive the entire project, it'll be good, and if not, I'm going to make sure that there's a plaque there commemorating my involvement.
Well, Chris, that sounds like a station. I won't say who it was. It wasn't WOR, but they were having some work done last year, and or maybe it was the year before. The contractor was digging with a backhoe, and all of a sudden, the chief engineer was looking at a 3.5-inch transmission line that was now severed.
Oh, they're my gold shovels.
Ooh, right. Now you're going to give them the politicians afterwards.
So somebody emailed or commented on that earlier today and said, "So where did you get the gold shovels?" And I went, "At the Plain Shovel and Gold Spray Paint store."
You should have said,
they came from Fort Knox.
Well, mine isn't in there. We're talking about my engineer in Madison, Tony, wants to pimp me out with a really nice, those are for the commoners. He wants to get me one that's like studded. It has like, a leather sheath on it and, kind of like the pimp shovel.
Yeah. Oh, where'd you get those gold shovels? Well, all those places advertising on TV and radio now that they buy gold. Well, this is what they do with all the gold they buy.
They turn them into shovels.
That's right.
No. I went to the latest political rally, and they just happened to be there. Anyway, ching.
Yeah. Bada boom, bada bing.
They turn the gold store turns them into gold shovels and monster cables.
Chris, listen. I sure hope that you will update us from time to time on this project. Whenever you reach a milestone or have something really interesting going on, I hope you'll take some pictures or even some video and share it with us. You will, won't you?
Oh, absolutely, sure.
Good deal. Good deal. Hey, we need to take a quick break here and hear from the sponsor of the show. They're paying for all of this, and I want to make sure that they get heard. It's the folks, some of the folks that I work for. It's the Omnia Audio division of the Telos Alliance, and I want to tell you about a product that's actually kind of new and kind of not new, but the good news is it costs less. This is the Omnia 11, and when the Omnia 11 debuted, and we're still shipping them out the door just as fast as we can. In fact, I've got one right here in my office that I listen to almost daily. The Omnia 11 is a full audio processor with both FM and HD radio sections in it, HD processing. But a lot of folks don't need the HD processing. Whether maybe you're in the States and you don't plan to go HD, maybe you're in Canada and you're not participating with HD yet at this point. Maybe you're somewhere else around the world or where you're just not going to do HD and you just want the FM processing. You just want the incredible sound of the Omnia 11. Well, prayers are answered. We've just announced that the Omnia 11 will now be sold in an FM only version, no HD. And the list price is $2,000 less than the FM plus HD version. So you get to save $2,000 on the Omnia 11 FM, and it's the FM alone version. The Omnia 11 has got just so many innovative things to it. Frank Foti and Corny Gould, Rob Dye, and Mark Manolio and others at Omnia literally spent years working on all kinds of different algorithms. And the whole goal of processing with an Omnia 11 was to make it sound as loud as anybody else on the dial, no competitive disadvantage at all, maybe even a little bit louder. But the real goal here was to be clean, clean, clean. No fatigue. Not have the processor sound like it's trying to be loud, but rather have the processor sound relaxed and natural. Sure, you can bring in some excitement if you want to, some lower bass, really punch it in there, and some high-end energy if you want that in there. Make the mid-range punch through and the vocals just print well on the radio. But if you want it to sound relaxed, that's fine too. And it's going to be plenty loud on the FM dial. And the way they did that, or one of the ways they did that, I should say, is by getting rid of intermodulation distortion on the various bands of processing. Now, this is quite a trick and requires a different technique for different bands. And the only way to really appreciate the work that they've done to get the Omnia 11 to sound so good is to try one. And now you can try one for less. You can buy one for less. You can contact your Omnia dealer. There's a whole list of them on the omniaaudio.com website. Find your nearest dealer. Get yourself a demo. Or, hey, if you buy one, we got a money-back guarantee on these things. An audio processor is a rather subjective purchase. So if you buy an Omnia processor, any of them, including the Omnia 11, and you decide in the end that it's just not what you want, it's just not for you, no problem. The company I work for, Omnia, and your dealer will work together to get you totally refunded if you decide that you don't want it. I don't think that's going to happen. So far, it hasn't. In fact, people keep buying more and more Omnia 11s. There's a little chain of stations out in Oregon that, these are not big city broadcasters, and they have bought 3 Omnia 11s since their introduction. Just a great box. Check it out on the website, omniaaudio.com/11. it goes to 11. You might want to check out the white papers on the website too, where Frank Foti really describes this ultra low intermodulation distortion. Check out, let's see, it's in the support area, and go to white papers, and you'll see where you can download papers from different authors, including Frank Foti. Also, a programmer's guide to the Omni 11 written by Denny Sanders. Denny, a fantastic programmer himself. So thanks again, Omnia, for bringing us This Week in Radio Tech. Okay, let's crank it back in here. Chris, we were talking to you about your big project in Milwaukee. I think it's a very exciting thing. And when do you expect your next milestone to be? When does something happen that's going to be really interesting to us as engineers?
Oh, 2016. It feels like it. I imagine probably not now for several months. We've got to get, once we get the parking lot done and we get the site grading done, then it's a matter of building the outer shell of the building. I mean, there'll be something to look at. It's not real technical, but it'll be the outer shell of the building. I'm predicting we'll probably start getting into studio outfitting and, design and things like that, cabinetry. Probably won't be until early next year, I would be my guess, because we're really not looking at having the shell done, or we probably won't be able to even start with all the permits and everything. We're looking at maybe August, September before we actually break ground on the building part. Now that could accelerate and change the timetable, but it's probably looking into winter before we really start on the inside.
So Chris, in a new facility, in designing one, I'm always curious about how you decide to run cables. If you have a raised floor like some radio stations and computer facilities do, or if you run them in conduits under buried in the floor, or conduits that go through the ceiling that come down in the rack room and then go over to each studio, or, do you do like I've always had to do at small market stations, get your butt up in the attic where it's 172 degrees and just pull some wire up there? How do you do it? And what are you planning for a new place?
Well, we still haven't nailed that down simply because we haven't finalized the layout of the facility yet. In Madison, when we did the remodel there a couple of years ago, I built some new studios there. We did a combination. We ran them up through conduit in the wall into the ceiling, then back down, and then we had a raised floor in the tech center where we have all the equipment. We built a raised floor and the wiring runs under it. In this situation, I guess it depends on where we end up with where the cabling goes. Now, we do have, for example, in the studios that are existing that we're going to tear out, there's actually conduit in the floor that goes into the floor and then up through the wall and then into the ceiling. And we'll probably just reuse that for the cabling. But as you know, we're looking at doing, or we're not looking at, we're planning on putting in digital consoles, which means a lot less wiring between those, all those different rooms, especially if we go with the new phone hybrids and things like that. We're looking at just running a bunch of almost nothing but Cat 5 in and out of there. So that'll certainly make a huge difference. But I'm also building a new tech core just for those studios in the addition as well. So, it just kind of depends on how that all falls together. Either way, it'll either, be conduit, through the ceiling or conduit through the floor. We just haven't gotten it down to determining that yet.
Tom Ray was involved with building a new studio facility a few years ago. Tom, how did you guys end up running your cabling? Was it overhead or in the floor? And how do you make that decision?
Well, it was in the floor, and for us, the area we built the studios was originally a computer room, and it had a raised floor there already, so we just reused the floor. Very bluntly, and if we did it in the ceiling, the problem with doing it in the ceiling in our facility is we got so many studios so close together, it would have been a little difficult to soundproof if we had to keep blowing holes in the ceiling to run the cabling in. Plus, there wasn't all that much room in the ceiling, so you need to take a look at how much room you'll have in the ceiling. You have to leave room for the air conditioning ductwork and for the studio lighting and for the whatever else you'd have to have up there. But in our case, running it in the floor worked out really, really well, and it was really easy to run. No ladders, just put a box down and pull. You were done.
Gotcha. And the same question then for Chris Tobin. Chris, you were involved at CBS Radio with a new construction here even more recently. How did you guys end up planning your cabling? And how do you decide? Floor, ceiling, some other way?
Well, actually, it was we decided based on we did it over the ceiling, cable trays throughout the ceiling, throughout the plant. Reason being, the building we moved into was a 1930s design, poured concrete, if you can imagine, 11, 12-foot high ceilings. So the thought process was, why not take advantage of the height of the ceilings? We'll do cable trays. It made simple sense. There are plenty of columns where we could bring cable trays down in a very clean manner and bring the cabling in and fan it out to the consoles, to the furniture, and the various studios. So the approach was to take that. And then the raised floor we wound up doing in one of the studios in a later construction, because that particular space, the ceilings, the way we had to design everything was smaller. So it made sense to go with a raised floor there, and that's how we accommodated. So we did a little bit of both. The space accommodated both approaches. It works well. I mean, raised floor, you can't go wrong. If you do it right, it'll grow with you for years. Cable trays do have a finite capacity, so you need to plan ahead, and hopefully you have enough space in the ceiling, as Tom pointed out. You need to keep in mind air conditioning concerns and other things, but you can make it work. And then all the cabling we used was shielded, even though we really didn't need to, because if you go by Steve Lempin's approach to cabling, you know that if you do it proper, shielding is half the battle in an environment like an office or studio environment, unless you have a transmitter. So your balanced pair cable, you should be fine.
So, and that question come up in the chat room, and actually we get asked that all the time. Hey, do I have to use shielded Cat5 or shielded Cat6 cable? And and I haven't been exposed to all the mechanical shielding methods probably, but what I've seen for Cat5e, for Cat6, the shielding methods, to a broadcast engineer like me who is familiar with really heavy-duty shielding when and where necessary, the shielding methods for category cable just don't look all that robust. It looks to me like you're depending upon a crimp and a metal-coated RJ45 crimping onto some foil inside the cable. And I don't know. It just doesn't seem that robust. And I've had better luck with unshielded cable because of the twist of this cable. It's very immune to certainly in a differential mode. It's not going to carry RF. Just in a common mode, it's going to carry RF, and most places where it connects to are going to also be fairly robustly immune to common mode RF.
Well, I think what you've experienced is shielded cable in the Category 5, Category 6 shielding. You're right. If you don't do it proper, what winds up happening is the shield now becomes a conductor, or we'll call it a part of the RF circuit. And I've experienced this on occasion. So I found just going unshielded, proper terminations on the cable ends, and 99% of the time, common mode rejection does its job, balanced pair cabling does its job, and you should be fine. I mean, unless you take a RF radiating device like a two-way radio and place it right on the cable, or stick it in the Cat5 bundle, yeah, of course you're probably going to override any common mode rejection. But normal conditions, you should be fine. But yeah, if you don't terminate properly with the RJ45 shielded connectors and the shielding on the cable, or it breaks somewhere because you pulled it, stretched it incorrectly, it actually creates more trouble than it's worth. But yeah, you should be able to find in most applications in a studio environment with non-shielded.
See, I have the added benefit of basically building a Faraday cage when I put these studios in, because we're located on a AM site. So we're going to put in copper screening in all the walls and ground all of that stuff. So most of the wiring is going to run, basically right into a Faraday cage to where they're going. So RF-wise, in fact, our building, we get a lot of complaints. You walk into our building and you get almost no cell phone service. So I plan to continue that with the new facility. I'm going to tap onto that system that we have now, and we'll actually have the walls will be screened in copper. So we really cuts down on we have no RF problems, and we're literally sitting right across the parking lot from a 50 kilowatt FM and a 5 kilowatt directional AM. So we'll continue with that method when we put on the addition.
Yeah, I've done that with transmitter sites.
I've got a picture that Burke is going to try to show here. It's one more picture from this transmitter site, the shortwave site, with, let's see, 2 100 kilowatt transmitters running, and then a third, I believe it was 50 kilowatt transmitter, but I could be wrong. So there's a lot of RF there, and you might say, whoa, you got a lot of RF problems there. Well, Okay, so there's an Omnia 1 processor on one of these shortwave stations, and I don't know for sure if he's using the live wire input on that or if he's using an analog or AES input. But if you scroll down some there, Burke, lower in the rack, there is an Axia IP audio node. Now, so this is one of the cool things that you can do with IP audio, and it doesn't matter if it's Axia brand or somebody else's brand. The idea here is similar. You use category cable carrying Ethernet IP for your longer runs of cable. And if you have a really long run of cable, you can do what, say, WoWo in Fort Wayne, Indiana did, and you can use fiber optic from between, say, the rack room and the studios. But cat cable carrying Ethernet IP is pretty darn immune to RF, as long as you've got connections tight and balanced and everything's right. So this is a fairly good way to get rid of RF problems at a transmitter site, is to use Ethernet IP with something like an Axia node, like we showed there, to get audio from one place to another. And then the actual audio runs from the inputs and outputs of the node, those are pretty short. And so they're not going to act like big antennas. They're pretty short. They don't pick up as much RF. And you can go to the other items that are just in the equipment rack, again, in close proximity to the node itself. And this works, as George McClintock showed. When we went to the SBE meeting out there, I had no idea that he had some Axia nodes out there. And he said, yes, we found it was a good way to keep the RF out. And I think they have some streaming computers out there, too. So what they do is they run the IP audio driver. Instead of running, cheap little 1/8-inch tip ring sleeve stereo unbalanced connectors to a sound card, they just run the Axia IP audio driver and get IP audio in and out of the PC that way on a nice balanced Ethernet IP connection. So anyway, it seems to work pretty well. And as we get more and more into that world, as long as things are balanced. Oh, there we go. There's a pump picture. Remember we were talking about that distilled water with a high amount of resistivity? That pump there is pumping water, distilled water, through an area where there is, 30 kilovolts or so on the plate of a tube, just to keep it cool. And there's a couple other close-up pictures. There's one of those, whatever it is, looks like an amplifier module of some kind, part of the modulator. There you go. Guys, we're out of time. Had fun.
That picture brings to mind the. You ever seen the cartoon Penguins of Madagascar?
Yes.
Yeah. The penguin who loves to walk around and blow things up. Kaboom.
Oh yes, I forgot about that. Yes.
That's all I can figure. You have a pipe crack, there's going to be a big boom in that transmitter.
Yeah. Guys, you got any parting words? Otherwise, we got to go.
I have one just to put out to everybody, for those who are from the New York City area and maybe elsewhere, but ham operators as well as broadcasters. About a week ago, Steve Mendelson passed away. And those of us in the New York City area know him from work at ABC and CBS, as well as with the New York City Marathon, and also game day frequency coordinator for the Jets games, Jets and Giants here in the New York City area. So I just wanted to pass that out. So a silent key for W2ML. And Tom, you know Steve, right? Or you worked with him?
Oh, I've worked with him and know him very well. And Steve was a great guy, and did a great job with a lot of things. Matter of fact, Steve was part of the reason ABC's Monday Night Football was on the air. He designed the first mobile truck for that, and he also, with the New York City Marathon, every year arranged the ham radio communications for the marathon, and that was his passion. And the Jets games, RF, and just a spectacular guy. You can't say enough good things about Steve Mendelson. You really can't.
Yeah, and one side note with Steve, when he was the game day frequency coordinator for the New York City Jets, for New York Jets, that is, he was showing off to one of the coordinators how to determine the RF interference and find rogue transmitters at the football game, and they actually came across a signal they couldn't identify, and later turned out to be a wireless camera that was videotaping the Jets' offensive coaches' signals. It was for the Patriots. It was a story that you could read about. It was 2009. So here he is showing somebody, a ham operator, or a broadcast ham operator, how to find an errant signal at a game and to make sure everybody's playing by the rules. And they discover that the opposing team was videotaping the other team's hand signals and coaches and stuff. I had to throw that in there.
Yeah, that's good. Well, sorry to hear about his passing, but thanks for relating those good stories. Gentlemen, we got to go. This Week in Radio Tech. We love doing the show. It was our 131st episode. We got plenty more to go and guests coming up throughout the summer. Chris Tobin from Manhattan, New York, the best-dressed engineer in radio. Thank you for being with us again this week. Appreciate you.
Oh, you're welcome. You're absolutely welcome. And Burke, thank you for production services.
And Tom Ray from the Hudson Valley of New York. Appreciate you making it home and being on the show.
Well, I appreciate being here. It's a lot of fun as always. And, we got to do it again sometime when we can't stay as long. No.
And Chris Tarr, thank you for reaching us once again from the Tarr Master Bedroom. I sure appreciate your participation.
No problem. Be sure to follow me on Twitter @TheGeekJedi and also check out broadcastengineering.info.
Yes, indeed. Both worth doing. Appreciate you very much. All right. And thanks to Omnia Audio and the new Omnia 11 FM. $2,000 less than the original Omnia 11 because it's missing something. HD. If you don't need it, don't pay for it. Thanks very much also to Burke McQuinn and the TWiT Network for providing us production and distribution services. We'll see you guys next week on This Week in Radio Tech. Bye-bye, everybody.